So good morning, everybody. My name is Sean Oshonuga. I work here as a PhD student in the Grenoble Electrical Engineering Lab, and today I'm going to talk very briefly about an open energy data lifecycle that we're building, which is very adapted to citizen and community-sourced data sets. So first off, open data has been gathering a lot of traction in the scientific community, also in government areas, and even from our word cloud yesterday, we saw that open data is a big thing for us. And so because of that, there have been many life cycles to model, okay, this is how open data should be treated, starting from when it's created until it's eventually used. So we have life cycles such as this. This is the linked open data lifecycle model. We have data lifecycles such as this. This is a lifecycle for digital curation of content. We have lifecycles such as this, which is by the US Geological Survey Society, which really just goes for plan to share, and that's the end of the data lifecycle. To a point where we have a lot of different data lifecycles that we can use to model how it works. But one of the things that we see is that the energy domain is severely underrepresented in the availability of data sets. As we see here, on the data.europa.eu website, energy is one of the lowest reporting data sets. And one of the reasons why we think that's attributed to is that energy data is actually multi-tiered. So there is energy data that is things from the commons, such as rainfall data, irrigation data, and all of that. There's data that is really about shared large-scale infrastructure like electrical networks, situation of dams, and then we had a breakout session yesterday where we spoke a little about that. But then most of the energy data is really at the individual scales with buildings, electric vehicles, and all of that. And many of these life cycles are not well adapted to do that. And so with that in mind, we then developed the OpenDAL lifecycle, which basically looks to learn the best lessons from what exists, but then applies it to a very specific energy level context. Some of the things that we included to this that were different were we specified what are the inputs and the flows between the different life cycles, and then a very important question that we've started to ask ourselves, and I would be very, very interested in hearing from everybody, is when we track use. For now, it's very easy to track use from scientific data sets, but for cases where the data is used for things like model training, that's not exactly clear how that is specified and how you measure impact in that case. So a very simplified schema of this, showing what is new to this data lifecycle is here. One of the things that we did was we separated self-use from data reuse, because in many of the other models, they lump them together, but that's actually not the case, because if you are the owner of the data, you definitely have more information, and then we added an extra layer for tracking use and user interaction. So feel free to scan this QR code. We have a paper that then attributes this life cycle to the Grenier building. It's the building used for research and teaching that we visited 2 days ago, and I will be willing to hear questions and comments during the lunch and other short breaks. But thank you very much.